All right. So does one problem look more difficult than the other, or both of them look difficult, or easy money? Easy money?
Sure.
Yeah, we like that. Easy money. Okay. One of these is a new problem. The other one is finding a different type of variable that you have not had to solve for yet. So, which one would you rather look at first?
Well, don't you have to do the first one? That's from the previous question.
Well, just making reference. The variable is there, but you can solve the first one to begin with. I mean, sometimes that typically does happen. That is true. You do need to solve the first one. But in this case, you do get a choice. The purple top or the black bottom? Okay. All right. So from the previous question, sometimes you do have to use a variable from here, but that is not the case. It says, how fast was the pig moving when it started? So if you did not go any further than that, is there anything that sticks out in your mind what that question is possibly asking for?
How fast was the pig moving when it started?
So when it started, and if it's moving, what type of variable is that? It's a velocity and it's an initial velocity, okay? So the time frame that this movement was 0.81 seconds, and the motion was 2.15 meters per second squared, okay? So, do we know anything, or what do we know in this problem? That science is awesome? Okay, yeah, besides that, we already know that. That's every day.
We have time and final.
We do have final velocity. You are correct. Okay? Because even though it says from the previous question, this is asking for when it started, and here's a velocity we're referring to from the previous questions. Okay, so what is a variable that we can write down? Okay? Is there a potential problem with that? When we look at our label, is there something wrong with that? Yes, there is. What is a possible problem with the way that this number is labeled? Why is that important? That's an acceleration. That's right. So sometimes we just kind of throw these little hiccups in there. It's motion, which can be velocity and acceleration. It's not always going to say this is how fast it was moving. This was the velocity. This was the acceleration. It's not always going to say that. So you need to use your science intuition, physics intuition. What type of intuition? Science intuition? Should we just go with that?
Sure.
All right. But we do have a final velocity. What is your final velocity from the previous problem? No. 6.78 meters per second. What else do we know? The time, which was what? Time was 0.81 seconds. What else do we know? We know the acceleration, which is what? Okay. Is there anything else that we could write down that we know from the problem? No. Because what are we essentially solving for? So we put that in the box. We're looking for the initial velocity. And it's something that you have not done before. Okay? So, we have our setup done. What possible formula are we going to use? Okay? So now, let's do what the formula tells you to do, which is we've got an equal sign here. What is on the left-hand side of our equation because of our acceleration formula? 2.15. What is on the right-hand side of our equation? Oh, I meant to put minus. No. Minus something.
6.78.
I do have 6.7. Oh, 6.78. I was just seeing if anybody was paying attention. Okay. So what's our unknown? Okay. Do we know anything else? Make sure we do this. Is there anything that goes on the bottom? Okay, one of the things, do a little bit of foreshadowing in here. What does it mean to foreshadow? We've got our play director and oral interp director here. Let's get this right. What does it mean to foreshadow something? You're looking ahead. So we're going to do some foreshadowing in here. It's going to be a little different because there's a negative value in front of that VI, but we will take care of that in just a moment. Okay, we said we don't like fractions. How can we get rid of this fraction? What have we been doing for probably the last 5 days maybe? And when you do that, why is that important? Are we changing the value of 2.15? No, it still has a value of 2.15. Okay? So this is where it looks a little different because what we've seen before is typically there's a 0 there, but that's not the case here. Okay? So, how do we get rid of these fractions? Cross multiply. Okay. Which one do you want to do first? This one or this one? It doesn't make any difference. Let's go ahead and do this one. What is 1 times 6.78? Okay. So 6.78. Okay. We got to carry that sign. What is 1 times this variable? It's the same thing. So we still have VI. Okay. So we've cross multiplied here. What do we do with these two numbers? Same thing. Now we got a nice linear equation. So what is 2.15 times 2? How much? 1.74. Now you're in familiar terms or familiar territory where you have solved one variable in your algebra class, right? And this is, again, a little different because we don't have this multiplication function. Because typically, you might see something like this. 6.78t equals, we'll say, 15. And from prior knowledge, how would you get that t by itself? You're going to divide because this is a multiplication function. Here, we're doing a subtraction function. So we need to get this VI all by itself. So how would we get VI all by its lonesome? If this is a positive value over here, how can we get this number over to that side? You're going to subtract, okay? So if we subtract this side, what happens to these two numbers then? Because a positive 6.78 and a negative 6.78 will cancel each other out. So what does that leave on the left-hand side? Negative VI, that's important. So what's going to be on the right-hand side of that equal sign? And there you probably need your calculator. You're doing exactly what you see here. You're taking 6.78 from 1.74. A little more, you're right, but a little more specific. Negative, okay? That's important because this number's bigger, but please repeat that, negative 5 point what? 04. Now, does anyone see a possible problem with this? Why is that a problem? What do we say about velocities, though?
It's always positive.
But I see a negative velocity there.
So you need to change them both to positive.
Can we do that?
Yes.
You're right, but why are you right?
Because
You just change them? Well, that's probably true, too.
Because they're both negative, so you can make them both positive.
What you can. And I'm just giving you a hard time. I want you to take negative 5.04 times negative 1. Negative 5. Yeah, you just make it positive, okay? Really all you're doing is just switching the sign. So you're illustrating by taking everything times a negative 1, or you can divide everything by a negative 1. And by doing that, that makes it positive, okay? So sometimes when you solve for these, you may have to try to find the initial velocity, and when that happens, you're going to get what you think is a negative value, but you just change the sides to make it positive. All right. Middle row. Are we on the bus here? Front row. Are we on the bus? Back left only, are we on the bus? Back right only, are we on the bus? Back right middle, are we on the bus? See how I'm doing that? Are we on the bus? Yes? And so back left middle. Yes? Yes. All right. We're having so much fun, Mrs. Anderson. Just look at all this fun.
It looks like lots of fun.
It is. All right, so with that, can we erase this? Yes? All right. So even so, you can always go back and watch this on the Science Channel, should you choose. How? Oh, you did. Should be some royalties with that, right, Ms. Anderson? Could be. I think it's a fan. Yeah. Because you know what kind of fans I have? True. They're up by Elkton and they're up by Lake Benton. These fans stand like 200 feet tall. I got the biggest fans around. We told a funny. All right. So, moving forward. Yeah, windmills. They're fans. Okay. So a feeder pig with a mass of 97 kilograms collides with a gate moving at 6.78 meters per second. What is the momentum? Okay. So which one of these variables is new that we have not talked about yet? That too. Mass. We have not talked about mass yet. So how do you think you're going to label mass? Because if it's velocity, we just use V. If it's mass, we're probably going to use... Okay, so our mass equals 97 kilograms. Okay? So this type of a label is telling us what type of variable do we have. Okay? It's a velocity And how did you know it was a velocity?
Because it was ms.
Because it's labeled in meters per second. Okay? Do you need more information? Yes, you do. Okay? This is why. Okay? So on your formula sheet, we want you to write the letter. You can use anything that you want. For instance, you can use X equals MF. You can use Y, or what the author says, the letter P stands for momentum. I would suggest that you don't use the letter M for momentum. Does anyone know why? Because you have M for mass already. Okay? So 2 reasons the author is going to say use the letter P or something other than the letter P, just not M. And what this typically means is the momentum equals the product of that object's mass times its velocity. Okay? There's 3 variables in this formula, so you have to know how many to solve for it. If you have to know 2 of them. So do we know 2 of these variables to solve for our momentum? Yes, we do. Okay? So now we just want to do what the formula tells you to do, which means our product is on the left or the right side. Our product of our, which means momentum, equals what's on our right-hand side. Okay? And so you can do it like this. You can do it like that. Heck, you can even do this if you wanted to. All 3 of those mean the exact same thing. I just prefer putting them into parentheses because I think that's just what works for me. You pick which works for you. Okay? And I think volleyball players, there's some of you, have you tried a jumping serve? Does that sound right for volleyball? Just jump serve. Has anyone tried to jump serve? Do you feel you are proficient, or that means good? Are you proficient at it? So it just means you need to work at it, right? Okay. So you just need to do that type of serve. Your type of jump serve might be different than over here. You need to choose which one works best for you. Okay, so what is 97 times 6.78? 57 point. Okay, now I forgot to put a box around what we had for an answer from last problem, which was 5 point something. Okay, but in this case, this is what we call a derived unit. Okay, when we label that, you're combining a mass and a velocity. So what is our mass measured in? Kilograms? Nope, we didn't square anything. Now, this means per, okay? In other words, let's say you're at the grocery store and the bin says $6.60 per pound for potatoes. So that means if you have 2 pounds, okay, if it's $6.60 per pound, you take 6.60 times 2. That's what we mean per pound. So this is a derived unit that kilograms per meter, then what's left over from our velocity, do you think? So we've accounted for this one. We've accounted for that. What do we have left over from our velocity? time, which is seconds. Okay? Because one of the, I shouldn't laugh at this, but this is one of the funniest things that I've ever seen. I think Ms. Anderson, you probably had heard this story. You remember the Zip feed mill in Sioux Falls? There was a construction company that was hired, and I bet you, what, maybe $5 million it would cost to hire them to come in. They're supposed to blow the Zip feed mill up so it would come tumbling down. This is about 2006, I think. They hit the button for the demolition, and oh my, it did not knock the Zip feed mill over. So once that happened, you can't go in and put more explosives in there. There's liability reasons that you just can't. So they had to do it the old-fashioned way, which means you bring a crane in with a wrecking ball. And then you bring it back here and let it swing away and knock it over. Because when you're talking about momentum, when that wrecking ball swings, do you think you might want to measure it in kilograms per meter over second? No, because that wrecking ball weighs tons, not kilograms. That would be a really, really big number. So whatever mass is given, you would do, maybe it's ton per meter over second. Maybe it's just gram per meter over second, because maybe you're dealing with tiny marbles, okay? Sometimes I lose mine. That means you're going crazy. I lost my marbles today. And then we slip. Then I don't want to lose my marbles because I'll slip on them and fall. Hopefully not. Okay. Any questions over this? Front row, we on the bus here? Second row, we on the bus? Third row, we on the bus? Was that? Yeah, okay. All right, very good. That's all I have. We'll get you your evaluation, and that will be it for today. Next week, it looks like we're going to start with your next paper, which will have some of these momentums on there, and you may be having to solve for some of these negative velocities. And I guarantee you, well, I think I can guarantee it, you may have to solve for a final velocity to put into another formula and another problem. Okay, that's all I have. We'll catch up to you next time, and I will collect your papers, make sure your names are on them.